Hey guys, in this video I want to go over my electronics and the enclosure for my G0602 CNC conversion. And I had this edited to about 40 minutes worth of me explaining the way I wired all of my stuff, the components that I used and why. And I've kind of been having a hard time with that video because most of you know I like my videos to be 9 minutes or less, and I couldn't quite figure out how to cut it up. So I've kind of been just mulling over this problem for about a month. And in the meantime, one of my friends on YouTube, his name is Sam. His channel is CNC 4XR7, and there's a link in the description. He started rolling out a series of his electronics for a Precision Matthews 727M mill that he's converting. And his videos are so good that I realized I don't want to do a video anymore. And Sam, if you're watching, that's a compliment to you. His information is really solid. Everything's very well thought out, very methodical. I'm going to highly recommend you go check out his channel. Again, check the link in the description. And instead of spending 40 minutes over 4 videos or whatever telling you about how I did mine, I'm just going to quickly go over each of the components and then refer you to Sam's channel. It's fantastic. So we're going to kind of work left to right, bottom to top. And on the left side of my panel here, you can see that I've got 2 terminal blocks. The one at the top is for 220 power coming in, and the one on the bottom is for 110 power coming in. Now, the reason why I have to have 220 is because I have a 220 VFD, and you don't need that. You do not need a 3 horsepower VFD for your G0602. In fact, for most benchtop machines, it's way overkill. And then also over on the top right corner is the speed control, the DC speed control for my mill. And that also requires 220 because it's a 2.8 horsepower DC motor. And so that's why I have 2 terminal blocks. If you're just doing one machine, you're probably only going to have 110 coming in. Most VFDs can upconvert 110 to 220 and then into 3-phase. Mine does not have the ability to upconvert. And this VFD is something that I purchased a long time ago for something completely unrelated, but I'm using it on the lathe now. And then next to the terminal blocks, you can see a kind of long, skinny, weird-shaped PC power supply, and this is providing 5 volts and 10 volts to my breakout board. The next thing is the big black power supply, and this one provides 48 volts to my stepper drivers, and that's necessary. And both of these power supplies are powered by the 110 terminal block that's coming in. Okay, right above the 10 or the 48 volt power supply are my 3 stepper drivers, and then to the right of that is the mill DC motor drive. Now, the way that I'm using this is I have one enclosure controlling both my mill and my lathe. So when I want to switch between mill and lathe, and I'll show you this in a minute, I unscrew some aviation plugs and I unplug the steppers from one machine, plug in the steppers from another machine. I have 2 different config files in Linux CNC. I run the config file for that machine, and bam, now that machine's running. Now, this does mean I can't run my mill and my lathe simultaneously, but I don't expect to ever do that in the future. I've never needed to do it in the past, so that's why everything's in one box. This small silver box is a line filter, and I put this in because I believe it was Sam actually that mentioned that VFDs can create a lot of line noise, and so you want to run power to the line filter and then to the VFD. Okay, now one more shot, and here you can see I've overlaid a panel, and it has my breakout board. There is a pulse index card. That's this little card down here. And then on the right is one of these really cheap 8 relay modules you can get on eBay. And this thing has been fantastic. I've been running my mill and my lathe on this enclosure for a few months, 2 or 3 months, and none of these relays have burnt out. They're rated at like 20 or 30 amps. It's been really solid, and actually about 2. So if one does burn out, I have extra relays on this board because I'm not using all 8, but if I needed to, I can easily swap in a new board if this one goes to crap. But it's actually been really good, so I haven't had to do that. Okay, so now we're going to step over to the to everything installed in the enclosure. Now, of course, this looks like a giant mess, and to you it should. To me, I know where everything is because I'm the one that built it. But you can see I didn't use, because I didn't have space to use any of that. I can't remember what they're called. The channels that you can route all of your wires into to make everything look super clean and organized. I just didn't have the room for it. I thought that I had bought an enclosure that was plenty large, but the reality of it is it wasn't large enough. So I'm not going to go through and explain everything. The only difference, or the only thing that's really changed since the last shot, is you can see that in the bottom of the enclosure there's a fan. That is an intake fan pulling air into the enclosure, and then in the top right corner there's an exhaust fan pulling air out of the enclosure. Now, these are a matched pair of fans that came out of an old server case, and so the CFMs match, and it doesn't make any weird hissing or whistling or droning or anything like that. So this system has actually worked out pretty well. I will show you one other view, and that is over here on the right side of the panel. You can see I've got the parallel port coming in, my aviation plugs for my stepper motors, and then a whole bunch of small grommets. I put in lots of small holes for different cables that needed to be routed in. This includes things like my pulse index card signal, so I can get a signal from the spindle encoder on each machine. Also, limit switches, that kind of stuff is coming in through here. I can't think of what else, but basically any other reason you might need to run a wire into the enclosure. And so all of that kind of data stuff comes in the bottom right. Power comes in the bottom left. And then you can't see it, but at the very top left corner, that's where the machine power to the motors goes out, in that top left corner, kind of tucked up behind the VFD. This one other shot is just the inside of the cabinet on that same corner. You can see all the wires coming in, and there's actually quite a bit more stuff going on than there is in this image, because this image is a couple of months old. But yeah, that's pretty much it for the enclosure. Let's see. I guess you know what? I guess I'm just going to end it right there. Again, if you have any questions or if you'd like to see something in depth, let me know. I am going to do another video on the three-phase motor install. That will be its own video. And then I'm also going to do a short video on programming the Hanyang VFD for those of you who buy this VFD. Although, again, I recommend you do not buy it. Buy a 110 VFD. Hanyang makes 110 VFDs. You could get a Tico, etc. But because there's not a ton of really great information on this VFD, that will be its own video. One more time, I'm going to say go over to Sam's channel, check the link in the description, and I'll see you guys in the next video.